Hello everyone, welcome back to uLearn Education Online channel. In the previous video, we have seen how to calculate the modulation index, carrier power, sideband power, total power and the current of an AM signal. Now in today's video, we are going to see the efficiency of AM signal, which means how to calculate the efficiency of AM signal and what the parameter of efficiency will define. As we know that the efficiency is used in order to calculate how much power is transmitted at the output of a signal. Okay, so practically or mathematically, the efficiency is defined as the ratio of output power to the input power. Output power to the input power. So this efficiency definition will vary based on the circuit explanation. Okay, so in an AM signal, this efficiency is defined as the ratio of useful power to the total power. Now what is the useful power? So for a transmission of a message signal, we are using a modulation technique. So for a transmission of an AM signal, we are using an AM modulation technique. So in an AM modulation technique, the sideband, either the upper sideband or the lower sideband, will carry the message signal information and the carrier signal doesn't carry the message signal information. So the power that is associated with the upper sideband and lower sideband, we are calling it as an useful power. So for an AM signal, the useful power is sideband power, which carries the message signal information, whereas the total power or the input power is PT, which consists of both sideband power and also the carrier signal power. Okay, and also this efficiency will depend on the amount of power in the sidebands in which the message signal information is carried and is received at the receiver. Okay, now in the previous video we have seen how to calculate the total power and the sideband power. So the total power PT is nothing but PC into 1 plus m square by 2, and the sideband power is summation of upper sideband and the lower sideband, and its value is AC square into m square by 4R. So I can write the sideband power in terms of carrier power as this is AC square by 2R, and which is equal to m square by 2. So AC square by 2R I can write as PC. So PC into m square by 2. Okay, so this is the sideband power. Now simply substitute the values of PSB and PT in the efficiency formula. So I am directly writing the percentage of efficiency as P sideband power to the P total power into 100. So P sideband power we have found, that is PC into m square by 2, and total power is PC into 1 plus m square by 2 into 100. So PC gets cancelled. Now take the LCM, then it is m square by m square plus 2 into 100. So this is the percentage of efficiency. So from this expression, I can say that the percentage of efficiency value will depends only on the modulation index. Since the modulation index value, we have seen the waveforms of an AM signal for different modulation index, that is m is less than 1, m equal to 1 and m greater than 1. Let us see the cases for different values of m. What happens to the value of efficiency? Okay, so let us consider the case 1, that is an under modulation, that is m is less than 1. I am considering the m value as 0. Okay, so if m value as 0, then what is the value of percentage of efficiency? Then it is eta is m square by m square plus 2 into 100. So its value is 0. It means the 100% of power will be wasted on the transmission of carrier signal. Okay, Now let us see the case 2. That is when m is equal to 0.5. So when m is equal to 0.5, then I can write the percentage of efficiency as 0.5 whole square by 0.5 whole square plus 2 into 100. So if it is simplification, then its value is 11.11%, which means only the 11% of power is used at the receiver end, and the remaining 88% of power will be wasted for the transmission of a carrier signal, which means there exists a huge amount of wastage of power for an AM signal. Now let us see, for m is equal to 1, what is the efficiency value. Okay, so for m is equal to 1, eta is 1 by 1 plus 2 into 100. So we are using efficiency. So it is equal to 1 by 3 into 100. So it is 33.33%. So here also we can see that 33% of power is used at the receiver end in order to retrieve the message signal information, whereas 67% of power is wasted for the transmission of carrier signal. So based on these cases, that is for m is equal to 0, for m is equal to 0.5 and for m is equal to 1, we can say that there exists a wastage of power for the transmission of a carrier signal. So this is how we have concluded the efficiency with different modulation indices value. Now here, why we are considering the values, that is m is less than 1. Why? Because in the under modulation and the critical modulation itself, there is no loss of information during the signal transmission of AM signal. So that is why we have to consider the values of m as less than or equal to 1. So for m less than or equal to 1, we have to calculate the efficiency. On calculating the efficiency, we have to make sure that, or we have to know how to reduce the wastage of power and how to utilize the maximum power while transmitting an AM signal and also recovering the message signal at the receiver end. Thank you so much for watching our videos. Please subscribe to our channel and keep supporting.